Hello, good morning, everyone. We're gonna try to finish the lecture 10 today. We have a few more slides with the bones, and then we're gonna move on to the muscle afterwards. Um, excuse me. Let's see where we left off last time. Uh, I believe we are going to do the pelvis next, okay? The pelvic girdle. Let me just go through the model with you first, and then we will do some labelings and make some notes there. Okay, so this is the pelvic girdle, and the pelvic girdle is consist of several bones on both sides. And at the back, it's connected to the bottom of your backbone. Does anybody remember the name of this bone right here? It's, we have the cervical, for the backbone, we have the cervical, thoracic, lumbar, and then below that, what is it? That's right, this is the sacrum. Yeah, I'll label it for you later if you don't remember. That's the sacrum. And you can see a little bit of the coccyx bone right here, the tailbone, right? And on each side of the pelvic girdle, we actually have three bones that are together, and it forms the coxal bone. Okay, Coxal, not to be confused with the coccyx bone. Okay, that's the tailbone right there. Is a Coccyx. This is coxal bone, which is Coxal. I'll write all these down for you in a bit. Now, the coxal bone is made up of like three other bones. Over here, number two. This is, oh, never mind, number two. This whole piece right here, that's the ilium. It sounds exactly like the intestine ileum, but it's spelled differently. Okay, this is Ilium, and you have the ilium on the other side as well. And this here is called the iliac crest. Right? So like if you imagine like standing and then just putting your arms right here, this is where your iliac crest is going to be. Sometimes we have something like a heavy box or something like you're resting on your hip. That's the um, iliac crest that you'll be resting the box on. Now, over here at the back, we have what's called the ischium. Ischium. And the ischium is the bone that we are sitting on right now. I am assuming you're sitting, okay? So that's the knob right there at the bottom. And at the front, we have another bone called the pubis. Okay, the two pubis bones at the front actually connects together with a bit of kind of like a cartilage here. It's called a pubic bone. Um, or the symphysis pubis. And it's just kind of like a cartilage that gives the hip a little bit of a flexibility. Now there is a foramen here, it's called the obturator foramen. This foramen is formed by the pubis bone at the front and the ischium right here. And this allows various blood vessels, nerves to pass through so that when we're sitting down, we're not going to be accidentally compressing our blood vessels or our nerves, right? They're all nicely tucked in this obturator foramen um, to, um, to be protected. There is another socket here, and this socket is as a result of three bones, the ilium, the ischium, and the pubis, and it's called the acetabulum. Okay? And the femur, your thigh bone, is gonna fit right in there to form a ball and socket joint. Okay, this area here is a little bit wider in female than males. That's how they know whether the skeleton is male or female when they find one. I mean, there are other cues as well, but this is one of the differences. And when the baby is born, the head has to be able to fit through this opening, right? That's why if the baby grows too big, it's possible that they won't fit through, and you will have to do a C-section for it. So that is our pelvic girdle. You can see this model, play around with it on Luminate. Now that was a lot of information already. We're only 5 minutes into the class, but here is the here's the diagram for it. It's from your study guide. So let's try to label um, as many things as we can. Let me see how this works. Oh, it's not. I just want to pull it down a little bit. Is it gonna let me do that? Oh, there we go. Okay, so this is the pelvic girdle. And like I said, the pelvic girdle is made up of various bones here. At the back, we have the sacrum. And all these holes, that's again where the blood vessels and the nerves can pass through as well. There is a bit of a tailbone right here. Tailbone are coccyx, like 3 to 5 fuse together. Let's do the 3 bones. Okay, so the biggest one is right here. We want to color a little bit into this socket. Okay, I just want to highlight the socket for you right there, and part of this bone is going to form that socket. Okay, so this bone right here on both sides. This is called the ilium. Ilium. The one in the intestine is Ileum. And this Ilium. And this location, this top part here, again, that's where you're gonna rest your hands on the hip. This is called the iliac crest. Now, in case you're wondering, above here, right, on top of the sacrum, that's going to be your L5. Okay? Remember your backbone, the lumbar section has 1, 2, 3, 4, 5. Okay, let's keep going. Let's do another one right here at the back. This is the one that we're sitting on, and it's gonna form a little bit of the socket as well. It's hard to define exactly where it ends, but roughly 1/3, 1/3, and 1/3 for each bone. And this is called This is called the ischium. That's how you pronounce it, ischium. And the part that you are sitting on, it's called the ischial tuberosity. I don't know who came up with these names, but that's what they're called. And finally, the third bone that makes up the pelvic girdle right here, uh, which also forms a little bit of the socket. I guess like we should go a little bit higher up here um, with the ischium. Sorry, with the pubis right here. Okay, so that I can go into it. Again, the boundary not isn't hard to tell from this diagram, right? You will have to look for like a fissure in a suture, fissure like a connecting point in an actual model, and there is the pubis. Okay, so together the three bones makes up coxobone. Now it's kind of running out of space on the left side. So we're going to go to the other side and I'm going to draw the socket again. It's the same socket on this side, and this socket is called the acetabulum. There's a message. The Oh, okay. Yeah, the whole thing is the pelvic girdle. Sorry, I might have misspoken. Okay, but these three bones makes up the coxobone. Okay, yeah. So there's this whole everything here is part of the pelvic girdle. Yeah, thank you. So this is the acetabulum, which is the socket for the head of femur. Femur is your thigh bone. Okay, just like the shoulder, you have the humerus fitting into the scapula and form like a ball and socket joint. Over here, we have the femur fitting into the acetabulum to form another ball and socket joint. Okay, so the femur kind of, I'll show you later, but like, you know what, it's gonna ruin the diagram. I'll show you later. Um, there's another thing here. This hole, again, that's where the blood vessels and the nerves can fit through and go to the legs without having to worry about being compressed when we're sitting. That is called the obturator. Obturator foramen. That is it. Now, this is in the PowerPoint, and I just want to put it here for comparison. Okay, this is like a side view of the coxal bone. There are some landmarks that we didn't talk about. I'm just going to cross them out. Yeah, never mind that. Okay, and never mind that either. Okay, so these things we didn't talk about. They are landmarks, okay? People like to have different names for various, protrusion knobs and processes. to refer to them because they are often muscle attachment points. But we're not going to learn all of them. Okay. So over here, you can see we have the ilium at the top, the blue part, and you can see this here is the acetabulum. And these little white things in there, that's the cartilage. Remember, you want cartilage in the joint to prevent wear and tear. And you can see over here, the acetabulum is a combination of all three bones of the coxal. Okay, ischium at the back and pubis at the front. I guess the one thing that I, excuse me, one thing that I missed labeling here is the cartilage that allows the two pubis to connect together at the front, and that is called the symphysis pubis. Okay, just right in the middle. Let me just double check. I think we covered everything. Any questions? All right, let me see if I can find a leg here somewhere. Um, I mean, I have a leg coloring sheet that you can download, but I actually don't have a leg model. Give me a second. I'll bring it over here. We will do the excuse me, we'll do the full skeleton again, but this time we're going to be focusing on the leg right there. Okay. So this is the left femur, left thigh bone, the leg, and you can see this is the head of the femur. Okay. Let me isolate it. How to isolate it? So there we go. Right. This is the longest bone of the body. Okay. Our height difference is primarily due to the femur. Okay? Like if we all sit up straight, like it's about the same height. So the backbone doesn't contribute to your height much. But once we stand up, right, then we can see substantial height difference between people. And so it's the femur that distinguish our height primarily. And the head of the femur, this thing right here, is gonna go into the acetabulum right here. Okay, delete that. Look, you see, acetabulum, which once again is consists of three bones. Maybe I'll show you one more time. Ilium, ischium, sorry, and pubis. Okay, top, back, front. That's the obturator for Raymond. And the cartilage is gone, but it's there. That's the symphysis pubis I was telling you about. Okay, let's put the leg back on. So this is femur. Okay, femur. Over here, the main weight-bearing bone for the lower leg is this tibia. Tibia. Okay. It's also called a shin bone. If you play soccer, you have to wear a shin pad. Okay. Tibia. And you can see the tibia and the femur actually makes a hinge joint, just like the elbow. There is a ligament that goes from the femur to the tibia. Okay, a ligament connects bones to bones, whereas a tendon connects muscle to bones. So there is a ligament that goes from the femur all the way to the tibia, and within that ligament, you will have your kneecap. Okay? Kneecap is called the patella. patella. Okay? Femur, tibia, patella. And on the side, we have the fibula. Fibula. Tibia, fibula. All right, let's take a look at the foot right here. The tibia actually forms your like the little knob on your uh, foot, right? On the side, there's a little round knob. Right? That's actually part of the fibula right here. And on the other side, that's where the tibia is going to be. And these bones kind of clamp onto this big bone here called, oops, the talus. Okay, talus. Right? Now, the talus is actually part of a bunch of bones in the foot, just like the carpals, right? How many carpals do we have? Do you remember? Anybody from last class? Hmm. There are 8 carpals, and at the foot there are similar bones, but we don't call them carpals anymore. We call them tarsals, and there are 7 of them. One, two, three, four, five. Oops, I hide it. Okay, again, one, two, three, four, five, six, 7. Okay, so 7 tarsals, Tarsal. And they all have individual names, but I only want you to know 2 of them. There's the talus, which forms the ankle with the tibia and the fibula. And then at the back, we have the heel bone. The heel bone is called the calcaneus. Calcaneus. Okay, so all these 7 bones are tarsals, metatarsals, and phalanges one more time. Okay, so that's that. Um, I guess we can um, draw, picture for it if you want. Again, nothing fancy, okay? But like, this would be femur, and this would be your left leg, front view. Okay, so you have the femur. You're gonna have 2 bones at the front. Okay, let's draw one bigger, and then you have like the smaller one here. Okay, the one on the side, that's the fibula. Tibia is the big one. And don't forget, there is a little thing right here. That's the patella. Okay, big bone right here for everything to sit on. That's the talus. Okay, and then big bone at the back. Calcaneus. That's the heel bone. Okay, and then 5 more. Okay, never mind the names of them, doesn't matter. Collectively, they are called tarsal. Okay, so the talus is one of the tarsals. Metatarsals, just like carpals and metacarpals. And the phalanges. Okay, phalanges. 2 for the thumb, big toe, and then 3 for the other ones. There you go. That's your leg, okay? Now there's this diagram in the study guide, all right? You can, of course, go and practice labeling it. Um, Again, that's all the bones we're gonna learn. Questions? All right. Let's take a look at shapes and different types of joints. Um, so we can classify bones by various shapes. I'm only doing 4 shapes. They have additional classification, but we're not gonna talk about it. Okay. So first of all, it could be long. Long is like rectangular in shape. Like generally long like that. So humerus. Anybody have other examples? Yep, femur, good. Maybe 2 more. Ulna, good. Fibula, excellent. Okay. Yeah, phalanges are short. Okay, I know it's still kind of rectangular, but they are short in that regard. Irregular shape is when it looks weird. So this is vertebra. Okay. Do we have another weird looking bones? Something that we learned, and then it just like strange shape. It looks something out of a horror movie. We saw one this morning, actually. No, everything looks nice and perfect. Yeah, which bone in the pelvis though? Okay. Yeah, yeah, that's good. Which bone? There, not all of them are weird looking, I would say. Like one is particularly strange looking. Uh, I would say the sacrum, right? Sacrum is irregular. Okay. I mean, look at the sacrum. Like that's just like not long, not short, not flat. It's just really weird. Okay. Sacrum. I guess the ilium and the pubis can also be irregular. Another one is sphenoid. That's in the head. The one that looks like a bat. That's irregular. Flat. We have a bunch. Okay. Parietal. What else? Maybe just like 1 or 2 more. Bones in the head. Sure, frontal. Yeah. Temporal. That's right. Very good. Short, like the phalanges. Okay. The carpals. Okay. I would say this is also irregular, the calcaneus. Okay. I'm not gonna give you weird stuff on the test, all right? It's gonna be straightforward. Okay. Like um you would know. You would know just by common sense whether it's long, short, flat, or irregular. I'm not gonna give you something like really obscure. All right. So here it is, a few more examples. Okay. Carpals are the short bone, right? Humerus, flat, irregular. I'm sure you can find more examples. Okay, joints. Joints are also called articulations. It's basically where 2 bones joined together. And there are three kinds of joints, okay? We have movable, which is exactly what it sounds like. It creates a lot of motion. We have partially movable. So um, not a lot of motion allowed, but you can move a little bit. I'll give you examples of that later. And we also have immovable joints. Okay, so those don't move at all. Okay, so let's look at movable joint first. There are six types of movable joints, and we have examples of it as well. Some are easier to visualize than others. So first one is pivot joint. Pivot joint, an example of that is atlas and axis. That's C1 and C2, right? Atlas and axis. Basically, a pivot allows you to swing in one direction. So shaking your head, right? That's pivot joint. A saddle joint is, for example, between carpals and metacarpals. So carpals is the wrist, and metacarpals are these um, bones at the back of the hand, right? So like basically these allows you to kind of move the hand like that. It's not really full rotation because if you try to do full rotation, kind of hear if you do it slowly and forcefully, you kind of hear the click as the joint kind of snapped from one position to another position. So that's a saddle joint. A saddle, it's like the saddle of a horse, or like you can think of the Pringles chips, Pringles chips. So if you have two of those chips and you just put them one on top of the other, um, sorry, one more time. You guys know the Pringle chips, right? Let me show, let me show you. I don't know if you know what I'm talking about. Pringle chips. This one. Okay, you can see the shape of it. There we go, right? So that's it's like the horse saddle as well. So if you take two chips, okay, but then you flip one and put it on top, then basically you have a saddle joint. Okay, so it allows motion kind of in one plane like this, and then in another plane like that, but not full rotation. We have gliding joints. Gliding joints, basically just one bone and another bone, and they just kind of glide past each other. Not a lot of flexibility right there. It's between the eight carpal bone there. Condyle joint. We also have one like from the C1 and the occipital lobe, sorry, occipital bone. But we also have some between the metacarpals and the phalanges and the wrist. Okay? Hinge joint is easy. It just goes like this, right, at the elbow and at the knee. And we talked about ball and socket joints already. Right? So it's much easier if you take a look at the picture here. Okay, so you see pivot joint is again allow you to have kind of not full rotation, but like limited rotation. That's what a hinge look like, and saddle. Right? I guess this is better way to represent it than than my chips analogy. But if you think about the red one and then the blue one here, not only can you go up and down like that, but there is a little bit of back and forth motion as well. Okay. Um, Ball and socket, coin and this plane joint is also called like gliding joint. Okay. Just no pivot, hinge, and ball and socket. Right? Those are the key ones that I want you to know, memorize, because those are the easiest one to visualize. These one is really hard to visualize, unless you have like a model in front of you. And believe me, I try to find models like virtual ones online, and I cannot find any interactive ones. If you find it, please email me. Okay, and then the partially movable joints would be like the vertebra. So our spine, it's kind of like stacking two chairs on top of each other, right? They fit kind of snugly, but you can still shake it, and there's like, a little bit of movement allowed. But if you have like a whole stack of chairs, then you can kind of visualize the whole stack can sway forward and backwards, right? So even though between each of the backbone, it's limited motion, but collectively, right, we have so many of these vertebrae, it offers reasonable range of motion. And immovable joints would be like the sutures in the skull, right? They are just set in place with no motion allowed at all. And it's a good thing. We don't want the bones of the skull to be shifting around. It's not very protective if they are like that. Okay, I'm sure if you were listening, you would know that the atlas and axis forms a hinge joint. Okay, hinge joint. All right, let's see if you remember this one. Go right ahead. The previous answer is did I say hinge? I meant pivot. Okay, for the previous, the answer is the pivot joint. Did I say hinge? I don't even remember what I said. Pivot. Pivot is the right answer. Sorry. Pivot. Hinge is like elbow and knee. Okay, what about this one? The acetabulum, which is the socket for the femur. What bones form the acetabulum? Okay, if you look at the notes here that we had, there are three bones that forms the acetabulum. Right, this circle here is acetabulum. We have the ilium, ischium, and pubis. Right, so it's A, B, and E. All right, let's do another one. Select all the long bones. Go ahead, all the long bones. Okay, so long bones, metacarpals, that's a long bone. Humerus is a long bone. This is flat. Tibia is long. So A, B, and D. Okay, A, B, and D. Metacarpals, these ones are long. Okay. Phalanges are short. Okay, that's that. My sister-in-law fell off the stairs recently, and she broke her uh bone in the foot. Um, what bone is this? This is her foot. Um, and can you tell what bone this is? That's right. That's the not carpals though, right? In the foot is not called carpal.
Also,
Tarsal, that's right. Metatarsal, okay?
yeah.
And can you guys tell which uh one is this? Is this like closer to the big toe or is it closer to the pinky toe? That's right, the pinky toe, right? So like she misstep and then twist and then fell and it broke. And she needed surgery, and there is a little wire in her now to kind of bind the bone back together. And she said it's like, of course, very painful. But it was interesting because now she has this thing in her, right? And she's better now, by the way. And then she needed to travel and she had to get a like a note from the doctor that says she has a this metal frame in her in case she set off the metal detectors at the airport. Um, but it never did. Okay, apparently it's so little metal. It's almost like wearing your glasses. If your glasses is made of metal, like it's not going to trigger it either. But if they scan you with the thing and then they go to the shoe, it might pick it up. But if you just walk through the scanner, it didn't trigger it. Um, anyways, so like you can break a lot of things, and sometimes the bone needs a little bit of support by putting wires and screws and things in it to for it to heal. All right, we are going to do another thing right here. I guess I'll talk about it first, and then I will fill in the uh, hormone table with you. So, by now we already should have a reasonable understanding of how hormones can work together to maintain homeostasis. For example, on your quiz today, you will have to know the hormone aldosterone is going to be working with the atrionatriuretic hormones to help balance blood pressure, okay, by regulating salt content and water content in the blood. Okay? So these hormones that kind of work against each other, we call them antagonistic hormone. And it turns out to maintain blood calcium level, we have a pair of antagonistic hormone as well. We don't want too much calcium in the blood. Too much calcium can um, cause problems. Like as we'll learn, muscle contraction requires calcium. So if you have too much calcium, then you might have like twitching of the muscle. They might be hyperactive. You also remember, I hope, in the nervous system, the release of neurotransmitters also requires calcium, right? And if you have too much calcium in the blood, then that would lead to a release of these neurotransmitters when you don't actually want them to be released. So, having the right amount of calcium in the blood is important. Too low, of course, is not good either. Then your muscle might not be responsive, for example. So you need to maintain homeostasis, a normal level. Okay? So, what happens if calcium level goes up? Right? If you have a calcium-rich meal or if you are taking supplements, what do you do with all those extra calcium? So, an increase in blood calcium level will trigger the thyroid gland to release a hormone called calcitonin. Calcitonin. Your thyroid gland is right here. Okay, thyroid gland is right here. Calcitonin is the one that can get big when you don't have enough iodine. Okay, so this is the thyroid gland, and it releases a hormone called calcitonin. How do you remember it? When calcium increases, you need calcitonin. Calcitonin. And what are we going to do? Well, calcitonin is going to promote calcium deposition in bones. You have all these calcium swimming around in the blood. What's the best place to store them? The bones. Okay. We have two kinds of cells in, well, three kinds of cells in the bones, but then for building the bones, um, we have those osteoblasts, right? So osteoblasts will take all these extra calcium and put them in the bones. And at the same time, the calcitonin will go to the kidneys and it will reduce the calcium uptake in kidneys. In other words, we are going to decrease the reabsorption of calcium. Just leave them in the filtrate, okay? Let them go out in the pee. We don't have to absorb them back. We don't need it. Okay, we have enough already. So these action will bring the calcium level back to norm. Okay. If you have a drop in blood calcium, you don't have enough calcium, then another gland is going to respond. Okay? These glands, they're called parathyroid glands. Okay, and they're located at the back of your thyroid. So if this mouse is my thyroid, and then I kind of take it out, and I look at the back of the thyroid, there would be four little glands right there. They are the parathyroid gland. And the parathyroid gland will release the parathyroid hormone or PTH. Okay, so PTH works opposite to calcitonin. Okay, and what does it do? Well, we don't have enough calcium at the moment, so we will absorb calcium from the bones. We will absorb calcium from the filtrates in the nephrons, and we will also increase calcium uptake in the intestine. But if you're not taking enough calcium, then this might not be an option. And if you don't have a lot of calcium in the blood to begin with, there might not be a lot to absorb from the filtrate either. So the only viable option is to take it from the bone, right? Which means if this is a consistent problem, if the person consistently not have adequate amount of calcium, then your body's just going to keep on absorbing it from the bones, and your bones going to get weaker and weaker and weaker, which would, of course, lead to osteoporosis. Okay, so this is spongy bones, and then with osteoporosis, you can see the spongy bone is becoming even more brittle, and is obviously not a good thing. Okay, so let's put this in the table to help you uh, learn it better, I guess. Hold on, I just gotta copy it over. It's in your study guide. There we go. So calcitonin. Right, so when we learn a new hormone, you always have to think of where is it from, what triggers it. Stimulus is the trigger, and what does it do on the target? Sometimes targets. Okay. So calcitonin. Where do we get calcitonin? We get calcitonin from the thyroid gland. And like I said, I'm not exaggerating. We're going to be learning more than 20 hormones between now and the end of the course. So you need to have a chart to organize them, to practice writing it, and to memorize it. Okay, otherwise the final test is going to be very challenging for you. Okay, so we already learned aldosterone, ADH, and ANH for the urinary system. And now we're learning calcitonin and PTH. So thyroid gland right here. And what triggers the release of calcitonin? Too much calcium in the blood or not enough calcium in the blood? What's the trigger? Too much or not enough? That's right, too much calcium. So high blood calcium level. Okay, when I say calcium, I'm referring to the ion form, not elemental calcium. So what do you do? What do you do with all these extra calcium? Oh, this chart is in the study guide, page 2 of the study guide. Okay, If not, it's okay. Just write down quickly. It's not difficult chart to create. Effects. What does it do? What do we do with all these extra calcium? We will increase calcium deposition in bones. Let's store them up. Put it in the lamina of the bone and reduce calcium absorption at kidney. Okay, leave the calcium in the filtrate, just pee it out. All right. People who overdose on calcium supplements, for example, uh, the extra calcium can start building up in the kidneys actually, and that is going to lead to kidney stones. Right? That is painful. Moving on. Parathyroid hormone or PTH. Again, this is the thyroid gland, and on the back there are four little knobs. Okay, this is the back. Okay, these little knobs, they are the parathyroid gland. And the trigger is low blood calcium level, not enough calcium. So what do you do if you don't have enough calcium? You're going to increase calcium absorption from bones, kidneys, and intestine. Okay, that's all. Now you got to be careful when you're studying this stuff, okay? Because the trigger is often opposite to the effects, right? Um, Over here, the trigger is high, it's increase in blood calcium level. The effects will actually lower blood calcium level. So collectively, these things will decrease blood calcium, right? Whereas over here, these action will increase blood calcium, right? So you need to know what is considered as a trigger and what is considered as the effects. All right, that's that. Uh, okay, I'll give you a moment to, catch up and copy if you need to. Okay, this is just to show you where the thyroid gland is if you forgot. We've seen it before, right? With when we talk about the larynx and the trachea and everything like that. And behind it, that's where you will find the parathyroid gland. I talked about that already. Here's another condition called rickets. If you have kids, your pediatrician, family doctor probably will recommend them taking D drops. And D drop is basically vitamin D, and we actually need vitamin D to absorb calcium into the body. Okay, and the thing about vitamin D is we need sunlight to for our body to make vitamin D naturally. But in Canada, the winters are long and we don't get enough sunlight. So ba babies who are born in the winter, they might not have enough vitamin D, which is why they are recommended to take supplements. And if they don't have enough vitamin D, then they are not going to be able to absorb enough calcium. And once they start to learn how to walk, the bones are not strong enough to support the weight of the body, and they get what's called rickets. Okay, rickets cause these bowl-shaped legs to form. Basically, the femur here and the tibia, they're just not strong enough, and they kind of bulge and curve um, as a result of too much weight uh, uh, put on them. Okay. But if people have the supplement, this would not generally be a problem. All right. Concept check. Okay, we just did this. Let's see if you remember. All right, so we just have to look at our chart. When blood calcium is low, the parathyroid gland secretes PTH. The answer is D. Okay, D. One more. Okay, well, let's take a look here. High level of calcitonin. Okay, again, you just have to look at the chart if you need a little bit of help. Okay. Basically, the question is asking you what does calcitonin do? Okay. So calcitonin will increase calcium deposition in the bones. You will put the extra calcium in bones. You will reduce the calcium absorption at kidneys because you already have a lot in the blood. Okay, you don't need to conserve more. So what do we do? Gonna increase calcium deposition in bones. Okay, a few people chose the first one, increase blood calcium level. That's the trigger for releasing calcitonin. Okay, this question is asking you for the effects of calcitonin, okay, not what caused it to be released. Okay, what does this do? This actually lowers blood calcium level. Okay. So like I said, try to fill in the chart a couple more times, draw those flow chart diagrams, and it usually would help. All right, that's it for the bones. I'm gonna skip the break today. We don't have a lot of slides left, just uh, a couple more. Most of them are pictures anyways. And we'll finish it probably in an hour, okay? And then you can go early and prepare for your urinary quiz today, right? There are two attempts. I want to emphasize that. Do not do it one after the other, okay? If you do it and you don't do well, then go study some more and then I try it again later on tonight, okay? All right, muscular system now. Muscular system. What does skeletal muscle do? Remember, there are three types of muscles. Skeletal muscle are the ones that you have voluntary control over. Smooth muscles are the ones that you do not have voluntary control over. Okay, they're like, in the GI tract or in the blood vessels, you can voluntarily control them. And then there are cardiac muscle, which is only in the heart, and you also cannot voluntarily control them. Okay, we're not going to be doing smooth and cardiac muscle. We will only be focusing on skeletal muscles. Okay, muscles that you can move and control. Right. Uh, we used to learn the names of the muscles too, but that's just like too much. Right? The bones are manageable for most people, but then the muscles are so hard because their names are very long. So I took it out. Right? We no longer have to learn the names of the muscles. But I'm sure you know a few, right? Like the biceps and the triceps. Okay, and then it gets crazy later on in like different body parts. So we're not gonna do that. Right? You can breathe out a sign of relief. Anyways, the skeletal muscle, what do they do? Well, they support the body. The muscle, like you are again, I'm assuming you're sitting here and we don't like just fall over because of gravity, because your back muscle is constantly contracting, right? And supporting your weight. Right? That's why even if you sit all day, it can be tiring because those back muscles, the lower back and everything, they are constantly contracting to help maintain the body posture and the weight and people can get lower back pain if their job requires them to sit too much. Make bones and other body parts move. Right? The skeleton cannot move on its own. Okay, like the hinge joint here between the humerus and the ulna is just a joint. It's not going to be able to move until something pulls on it, right? And that something would be the skeletal muscle. Maintain body temperature. If you're cold, you shiver. Shivering is contraction of skeletal muscle, and the shivering generates heat, which will warm you up. As we are walking around, the calf muscle, for example, helps circulate blood, right? We learned about this way back in lecture one with the venous return, and the muscle is kind of serving as a pump to cause the blood to move forward in the vein, as well as emptying the lymphatic vessels. Remember, lymphatic vessels do not have a pump, right? So it's relying on solely the skeletal muscle movement. They also protect the bone and internal organs, because they are more superficial to the bones. Some some parts of the body have more muscle around the bones than others. Like there's not a lot of muscle between the skin and the skull. Okay, there is a muscle there, but it's very thin, so not much protection there. But like if we're talking about like the bicep and the bone here, there's a long way through the bicep before it gets to the bone, so that offers some degree of protections. And of course, they help stabilize the joints. All right. We're gonna draw another picture. I'm gonna show you what it looks like. I don't think you're gonna like it, but we will draw it and see. Where is it? Is this guy? Okay, we're gonna draw this thing. Okay, it's think of like a cone, and then we're gonna pull something out, and then we're gonna pull something out, and then we're gonna pull something out. All right, and this is gonna show you the organization of the muscle. All right. So here we go. Again, like I personally think this is a better way to learn it, drawing it out, uh, rather than just looking at it from the slide. So muscle organization. Muscle organization. So we're gonna have, let's say, a bone right here, okay, and attached to the bone would be a muscle. Okay, not all muscle look like this, but this is the easiest one for you to visualize. There is a muscle right there. Okay, and this is the bone that it's attached to. Obviously, there's going to be another bone up here, but let's not draw too many things. This is muscle. And the muscle is going to be connected to bone through the tendon. That's going to be the bone. Okay. By the way, muscle can only pull. Okay? It cannot push. Right? They can only contract and get shorter. They do not get longer. So what we will do is we're gonna slice this guy open. There we go. And we're gonna take a slice of it. Now you should be doing this sideways, okay? I guess too late now. Sorry, didn't warn you. We start here and then we're gonna keep on pulling things out as I show you. All right? Okay, so here we go. Uh, Again, I haven't drawn this for a while, so bear with me if I have to make some corrections along the way. There we go. This is the muscle. There we go. We cut it open, right? That's why it looks like this. Cut it open. Right? It would be like the bicep muscle right here. And you kind of, if you prepare meat, right, if you buy beef and cut them, you kind of would see the structure that I'm about to show you. Right? So anyway, that's the tendon. That's the tendon. Give me a second. I am just trying to find a picture to show you. Anyways, no good pictures at the moment. So this here is the tendon that connects to the bone. And this whole muscle surface is actually covered by a thin layer of connective tissue. Okay, so I hope you have colors, highlighters. There we go. It's going to be covering the entire muscle surface. Right? So that is called the epimysium. It is connective tissue that surrounds the entire muscle. Epimysium. Now, inside like if you look at the cross section of a muscle, you will notice there are little individual bundles like this. And again, like people say, when you cut beef, you have to cut against the grind, the fibers. That's what we are talking about. I was trying to find you a piece of beef picture. I couldn't quite find one, but anyways, next time you buy beef, right, and it's harder to see on the chicken. It's more obvious on the beef. You know, the beef has these lines, right? These lines. Okay. So like if you prepare the beef, you have to cut perpendicular to these lines. So it's not going to be too tough. If you cut parallel to them, it's going to be really tough. So once you cut it open and you look at the cross section, you will notice these individual uh, bundles, if you would. Okay, so we're gonna take out one of these bundles. Okay, and so we just take this guy, and then gonna take it out like this. Okay, and we're gonna look at the cross section one more time. Okay, so I'm just gonna erase these things to make it look better. You don't have to. There we go. Okay, so this whole thing that I just took out, this whole thing that I just took out, this is called a fascicle. Right? A fascicle. Muscle fascicle. I'll tell you what a muscle fascicle is, but a whole bunch of these muscle fascicles is going to make up the entire muscle. All right, so there is another muscle fascicle. Okay, another fascicle here is like all of these are fascicles. Let me see again if I can find a picture. This is kind of illustrates it, I guess. Like if you oh, this is on Twitter. I don't know why this is on Twitter. It's too small. You can't see it. Uh, let me see if I can zoom in a little bit. No, never mind. Not good. Uh, anyway, you keep drawing for now. Maybe I'll be able to find a nice picture. Maybe next time I will take a picture when I'm cutting them. Anyways, that's the fascicle right there. So what is the fascicle, right? Well, the fascicle, before I tell you what it is, it actually is surrounded by an other layer of connective tissue. Okay, right there. Another layer of connective tissue. Right there. Oh boy, what have I done? Another layer of connective tissue. And this is called Instead of the epimysium, it is called the perimysium. Connective tissue that surrounds a fascicle. Now, this next part is a little bit hard to visualize, but bear with me. If you peel away the epimysium, the blue stuff here, if you peel that away, then immediately underneath, you will see the perimysium. Right? Each of these muscle fascicle is surrounded by the perimysium. And so that's why there's this purple outline that goes around each fascicle. Okay, there you go. Now, between the fascicles, what you will find would be blood vessels. Right? So you might have uh, arteries there. You're gonna have veins, right? And also, you will have nerves, right? Nerves here and there. So that's nerves, and these are blood vessels. Okay. So what is a fascicle? A fascicle is a bundle of muscle fiber. And muscle fibers is another word for a muscle cell. A single muscle cell is called a muscle fiber. So within the fascicle, you will see the individual muscle fibers, individual muscle cell. And these muscle cells are not like your typical cells that looks like, you know, spherical or like um, circle and rectangular. These ones are really, really long. Okay, so I'm gonna go ahead and pull one out again just to show you. Okay, it's like a Russian doll. Keep on. They're like nested, one within the other. Okay, so each of these are individual muscle fibers, which once again, it just means a muscle cell. So hundreds and hundreds of cells in a bundle, in a fascicle, and then you put a bunch of these fascicles together, you get the muscle. All right. As an analogy, uh, I guess we can think of it like this. Okay. Oops, that's the wrong one. Sorry. I'm gonna put it back on. There we go. It's like a package of crayons. Okay. So each individual crayons is like a muscle fiber. Okay. And then you put them together in a whole pack. This whole pack is a fascicle. Okay. This whole pack is a fascicle. And then you're gonna kind of like shrink wrap this thing. right? With those plastic cellophane things, shrink wrap it. The shrink wrap would be like the paramecium. Okay. And if you buy a whole bunch of these things, if you buy a whole bunch of it from Amazon or something, right? This whole thing would be like the entire muscle. Do you understand? Right? So the muscle has individual fascicle, and then each fascicle, if you open them up, you will see the individual muscle fibers. Right? So it's like, and as an analogy, it's kind of like that. Do you guys have any questions for me? I'm not sure if I'm doing an okay job here. There is a picture in the study guide. Yeah, I know. Like this one, right? Yeah, but I want to draw it out with you guys to, yeah, there's a drawing right here. I was trying to look for like an actual picture online, um, of like the beef to show you, but I should have done that before coming to class, eh? Anyways, the muscle fibers right here, muscle fiber, it is going to be covered with, it's going to be covered with another layer of connective tissue. Okay. And so once again, if you open up the paramecium, you will see immediately each of these muscle fibers will also be surrounded by these connective tissue. And the name of it is endomysium. Okay, so epimysium, perimysium, and endomysium. This is connective tissue that surrounds a muscle fiber. So this is already an individual cell. Okay, this whole thing is really long, right? Depending on how big the muscle is, some is longer, some are not. This is a muscle cell. Muscle fiber is a muscle cell. Okay? So like here, that would be like the cytoplasm with all the organelles in there. You know, mitochondria, Golgi body, and all those things. Okay. But one very distinctive component of a muscle cell compared to, other types of cells is that throughout the cytoplasm, they have these really, really long fibers. And this is the last time we're going to pull things out, okay? This is it. I'm not going to draw anymore. Okay, so let's take one of these things out. Let's take one more of these things out. There we go. Right. Okay, so these things that are found throughout the cytoplasm, they are called the myofibril. Myofibril. And the myofibrils are actually cut into little repeating sections. Okay. So each section is called a sarcomere. Sarcomere, which is the contractile unit of muscle. Okay. Sarcomere. Now we're going to learn more about the sarcomere in a bit, but you just kind of have to believe me that the sarcomere is made up of various proteins, and these proteins will arrange themselves like this. Okay, there are some. All right. Now I want to kind of expand a little bit more details for the muscle fiber. Okay, so I'm going to draw a muscle fiber here for you one more time. There we go. It's really, really long, okay? And I told you already, the muscle fiber is surrounded by this connective tissue. This connective tissue has a name. We wrote it down already, but let's write down again. It's called the endomysium. Now, if I peel back the endomysium, what you would see underneath would be the cell membrane. Okay, so this here would be the cell membrane right underneath it. After all, the muscle fiber is a cell, and the cell has a cell membrane. Cell membrane. Okay, think of the crayons again. The individual muscle fibers, the individual crayons, they have their own wrappings, right? The paper wrappings. Right? That's like the cell membrane around it. And the cell membrane, uh, everything in the muscle, they kind of give it like different names. Okay. I'm just gonna write for you. It's called the sarcolemma. Okay. Everything is sarcomere, sarcolemma. So it's just same as cell membrane, but they gave it a special name. And remember, in the cytoplasm, you would have these individual myofibrils, right? Okay, I'm just gonna label it for you again. These are myofibrils, which contains repeating units of the sarcomere. So one of these fibers, each of these fibers actually is gonna go into the cytoplasm. Okay. But what I'm trying to show you is this. This part is a little bit challenging to draw. Surrounding these myofibrils are a network of endoplasmic reticulum. Okay, so there is these ER. Okay, I guess we can just draw it like this. There's these endoplasmic reticulum that surrounds them. Okay, they are just endoplasmic reticulum. Okay, but again, like I said, because it's muscle, the people likes to give it special name. So it's called sarcoplasmic reticulum, but it's the same thing. And just last thing, these sarcoplasmic reticulum are connected to special tubes that will go all the way to the surface of the cell. And on the surface of the cell, there will be openings. Okay, I'll tell you what those openings are for later. Okay, but these tubes, they are called T-tubules. T-tubules. Okay. And the key thing to know here is that the sarcoplasmic reticulum, they contain calcium ion. Okay. And as you will see, these holes will allow action potential to come down and trigger the release of the calcium, which in turns will cause muscle contraction. Okay, so that's that. So I want to show you the pictures from the PowerPoint over here. Again, we start with the entire skeletal muscle, and the skeletal muscle are surrounded by the epimysium, the connective tissue. And what's inside the skeletal muscle? Well, it's a bunch of these fascicles. Okay, and if you pull out the fascicles, all right, like here, they pull out the fascicles, and you can see the fascicle is surrounded by the perimysium, and the fascicle contains muscle fibers. Each one of these is an individual cell, right? Very, very long. And when you pull this out, you can see it's surrounded by yet another layer of connective tissue, the endomysium. And this right here, this would be the sarcolemma, which is the cell membrane. And inside the cell, you have all these mitochondria, you have the myofibrils, and the myofibrils is surrounded by the sarcoplasmic reticulum, which contains calcium. Okay. These yellow tubes, they are the T-tubules I tell you about. Okay. T-tubules. And then we have the sarcomere, which I haven't explained yet. Okay, just a couple more slides, and then I think we can call it a day. Okay, so over here, uh, it's just a more comprehensive picture. This whole thing is a muscle fiber, a cell. You can see various structures here. Sarcolemma, cell membrane. Sarcoplasm is cytoplasm. And you can see the sarcoplasmic reticulum with all the T-tubules. And they all lead to an opening on the surface of the cell. Okay. Now, if you take a closer look at the myofibril, okay, these are just questions you can do yourself. The myofibrils are very, very small in diameter, and as I showed you, the entire myofibril is made up of repeating units of sarcomere. One of these is a sarcomere, another sarcomere here. They are joined end to end. And the sarcomere consists of several key proteins. And we have the thick one, which are called the myosin. And then the thin one, we have actin, tropomyosin, and troponin. Okay. So I think we're gonna stop here. And next class, we only have like a few more slides here to go through. Next class we will finish talking about how these various proteins will come together and create a contractions. We're gonna go through a few diseases related to muscles, and we'll also start on the reproductive system. Okay, but I think it's a good place to stop right now so that you have time to at least put in one attempt of the quiz before your next class. All right. That's it. Thank you. See you all next week.
So please, how many hours is the quiz?
The quiz is I don't remember. Let me take a quick look for you. Um, the quiz is let me see. Quiz number 3. Um, oh, I forgot to put in a time limit. Okay, I'll do that. I'll do that. Probably like 40 minutes maybe. Yeah. Okay. Thank you for reminding me.
Uh, that was bad or not?
Is that bad or I don't know. I'm gonna put in the time limit here for you. Okay.
Okay, boy.
Okay. Bye bye.
Okay.